Hello everybody, welcome to Six Sigma Green Belt lesson number 30. Under the table of contents on the right hand side, today we'll be talking about section number 3 and we'll be discussing lean concepts and tools. Under lean concepts and tools, we'll be talking about Kaizen Blitz, mistake proofing, any non-value added activities, and then finally constraint management, which is the theory of constraints. So from what we have found out in the industry is what happens is Kaizens, they take, just by the nature of it, they take a long time to get the job done or to resolve an issue. So because it's time consuming, there's a different strategy that we can use, and that strategy can be termed as a Kaizen event, Kaizen workshop, or a Kaizen Blitz. It involves Kaizen activity in a specified area, and the aim is to get the job done or to resolve the issue within the shortest amount of time possible. Generally, it takes a cross-functional team, and having new set of eyes to look at a process is always good. So having a cross-functional team adds value to the Kaizen event, and these events, this different kind of strategy, it can be done within 3 to 5 day period. So it does not have to take months or years to get the Kaizen done. We can do this by doing the Kaizen Blitz, Kaizen workshops, or Kaizen events within 3 to 5 day time period. And what happens is, because it's quick, you get to see the results rapidly, and the team, if it involves a specific department, if it's concentrated on a specific department, you can involve the individuals that have more knowledge in that area for each process, and you can put them on the team, including some other people from the different department, because a new set of eyes, as I mentioned, is always better to have. These Kaizen Blitz, they always require a facilitator because there's a lot of work involved. You have to do a lot of time studies, you have to study the current process, understand where the gaps are, see where the improvement has to be made. So it needs a facilitator. And by doing a Kaizen event, these following metrics can be achieved. So if the team decides that they can get rid of all extra space that is not needed and kind of shrink the cell to where that's to what it's needed, we can reduce the amount of space floor, and then line has more flexibility, the workflow gets improved, and then there are improvement ideas that get implemented. The quality also goes up because you look at different things when you do a Kaizen. You look at the safety, quality, productivity, any inventory issues. parts availability issues. These are kind of the things, the metrics to look for when we're doing a Kaizen. Again, safety, we can reduce safety issues by doing a Kaizen Blitz. And then the most important is to eliminate the non-value added activity. Mistake proofing, I'm sure a lot of people must have heard about it. It's a Japanese term called poka-yoke, and Mr. Shingo, he's widely associated with this terminology. Basically what poka-yoke means is mistake proof the process. Mr. Shingo, he recognized that humans or human error does not have to create resulting defects. Quality should be built into the part itself. It should not be dependent upon an individual. So the main purpose of the poka-yoke is to catch the mistake before it translates or before we produce a non-conforming product. So that's what mistake proofing means. And that's the purpose of the poka-yoke method. There are a lot of different approaches you can take to mistake proof an area or a process. You can use certain types of gauges or gadgets or devices. So, for example, if a machine is out of resin, an injection molding machine is out of resin, it sounds an alarm and it stops the machine. So it's a system built to make sure we don't make any bad products and that we are eliminating waste. If you have some kind of a, let's say you want to make some parts and you want to make sure you have all the parts that are needed, you can have a specialized tray or a dish so that each part has a space for it, and if a part is missing from that space, you know you don't have all the parts. So it's more of a visual system, a mistake proof system. There are other numerous screening devices that can be used in the fabrication and manufacturing industry. The author of this book, they have seen applications, mistake proofing applications based on the dimensions and the weight of a product. For example, if you go to McDonald's or Burger King or some kind of a fast food area, you'll see they'll have a product description on a receipt or some kind of schematics. So when you buy the product, it says you bought a Big Mac or a burger or a set of French fries, small or large. So those are kind of systems that we put in place to error-proof the process. Another good example is of having barcodes on the inventory items in the supermarket. Let's say you want to transfer a material from one location to another location or from one building to another building. Instead of manually doing the transaction, you can put a barcode and then scan the barcode and then let the system take care of the process. So this eliminates a lot of data entry activities and it does save time. So if you notice, mistake proofing is a preventive technique It's not a corrective, because once you're doing a corrective, it's too late. You want to prevent before the problem occurs. So we talked about this in the previous slide. And also, when we are doing mistake proofing, it does not have to be an expensive process. You can be creative, innovative to come up with inexpensive items to install, and you can also do that in a group environment so that the group can see the results right away, and it motivates, keeps the morale of the team higher. So if an individual is unable to come, you can put a team together and do a brainstorming session to come up with the ways to eliminate the error areas of error processes. There's one disadvantage, and that is when, let's say, you have to come up with a specialized technique to make a product. You may need an engineer or additional resources to get the job done. So resources are always a constraint and is an issue, but it's always, if it's possible, try to get the required resources that you need to get the job done. It's just a disadvantage if you're doing that kind of process improvement. Listed below, you can read through all of them. These are the processes that can be improved by making a design improvement. For example, first one is you can eliminate all the products or parts that cause a lot of issues in the system and build a safe, fail-safe system so that if it becomes a safety issue, the machine automatically shuts off. And also, you can enhance the product producibility and the maintainability of the product, and try to use parts or products that you know are good and are going to be lasting for a period of time and are proven in the industry. Non-value-added activities. This is also the other name for it. In Japanese, it's called muda, and I'm sure most of you have heard about it. It describes a waste that exists in the process. Whenever we are making a product, we do perform a work. So there's some kind of work applied to the process or to the operation. The only useful activities that we do is what the customer is paying for. Anything that the customer is not paying for is considered non-value added. And that's what this means here. He provides 7 waste opportunities, and those are overproduction of the material, the finished good or WIP. Second one, again, when you're doing that, it goes against the inventory, and the inventory levels, they rise. Other is making too many repairs, or then we have too many rejects on the line. Doing unnecessary motions which contributes towards waste. The other one, fifth one is overprocessing. And anytime a person has to wait for a material, that's considered waste. Any method of transportation to deliver products is considered waste because the customer is not paying for that, and is a non-value added activity. So talking about overproduction is mainly what it means is if we produce more than that's needed, let's say if we don't have Kanban card system in place and we have a push system, we may end up making more than that's required, and that's considered overproduction, or making it sooner than it's needed. That's number 2 here. And number 3 is making it faster than required, because if you make it faster, the next process may not have the space to keep the parts, and then it creates a mess when you have extra parts lying around in the area which are not needed, and that can also contribute negatively towards any safety issues. So these 3 examples are good examples of overproduction. We talked about this in the previous slide, so we'll talk about this paragraph right here. So when you have a just-in-time environment, a JIT, producing too early or producing too late, it has a negative impact to the business. We need to have a system in place so that the parts are available and they are at the location, specified location when we need them, and according to the schedule. And that can be a Kanban card is a good system, a good signal to produce. Until you don't see a Kanban card, you don't make a product. So that's a good system to have in place. We touched on this, having a product too early or too late, or in quantities that are way too much. It does result in undesirable conditions. You may have to have extra storage space. You may have to buy extra raw material because we consumed the raw material earlier, and now we need more raw material to make additional parts, or the line will be shut down. And then we need extra transportation to deliver those parts, and it goes back to scheduling production control to schedule more than that's needed. The second type of waste is inventory, and these are everything that we produce along with the raw material, along with the WIP, work in process, any items that we have in inventory, the supplies, again the finished goods, they're all considered inventory. Inventory is considered muda because it's a waste and it does not add value to the product. And another thing with inventory is it's money. There's a lot of money sitting there if we don't need those parts. So we should not have too much inventory and only have the required amount that the customer needs and when they need it. In addition, we can make extra inventory, and that can have a negative impact because of, let's say, warehouse damages or material handling issues. And if the product is sitting way too much, it takes too much time sitting on a shelf, it goes against the functionality of the product, because most of the products, they do have a shelf life, and creating extra inventory is, we're just looking for mistakes to happen. So it's always good to produce what's needed when it's needed and per the schedule. The other waste is the repair rejects. Anytime we have a defective part, there are additional resources required to take a look at it and disposition those parts. So either we try to salvage the parts or we scrap the parts if they're no good. So there's a lot of extra time that gets wasted when we make a non-conforming product. As a result, the scrap can go up, which is a definite waste, and it defeats the continuous flow, because now when we scrap what's needed, the next operation will have to wait until the parts are produced and until the good parts are produced. And this, your tag time, which is your production time available divided by the customer demand, that tag time goes off track when we make any non-conforming products. Again, we touched on this a little bit. With any non-conforming products, it needs additional resources and additional documents to be generated to disposition them. So that is muda, that's a waste. So continuing with the non-value added activities, another type of waste is the motion. We have to make sure that whenever we perform a job, we're doing in a manner where it contributes to the well-being of the person, of the operator. Any extra, additional, unneeded motions are wasteful. And for example, you have to reach way up there to grab a part, and you have to bend or lift heavy material and do all these unnecessary motions. They are considered waste. So what we have to do is, to correct this, we need to come up with better layout of the cell and better fixtures and tools and equipment, so that we eliminate the waste of motion. Mr. Sharma here, he suggests that we create a workplace to fit the employee and redesign the equipment or the necessary tools, so that we don't have too many safety issues in the company. The other waste is the processing waste, and this does consist of additional steps or activities that are performed when you make a product. For example, let's say if a part has too many burrs, and then you send it to a deburring department to remove the burr. That's a waste. Any reshaping or modifying a part because the dies to make the part, they're old or they're used, and they cannot make a good quality product, and then we have to do additional steps to make a good quality product. That's considered waste. Any extra handling, material handling, due to over processing, due to too much web, that's also considered waste, because now you need additional space to put those parts in. Inspection is always a non-value added activity. Quality should always be built into the part itself. And maintaining extra copies and having just too much information is always considered waste. We only need what's needed, and that's all to get the job done. So we talked about this in the previous slide. Another type of waste is called waiting. And this happens whenever a person or operator is ready to perform the operation but is waiting on the parts. And this is considered waste. And it negatively impacts productivity, and the company loses money on it. So if a person is waiting on parts due to machine downtime or parts availability issues or line stoppages, these are all examples of waiting waste. Another one is a maintenance operator holding onto a tool bin and waiting for the part. This is also waste. And anytime we have long changeover times, that's considered waste. And also if we have uneven scheduling of the work, we are jumping around too much, that's considered waste. We should always aim to level load a schedule and production. Also, not only on the production floor, but even in the meetings. If we try to schedule meetings for 1 hour every time, that's just waste. Meeting by itself is waste because the customer is not paying for it. It's a non-value added activity. Transport. So we talked about this earlier. Any kind of transportation that is used to deliver a product is a waste, because it's non-value added activity and the customer is not paying for it. This can include using forklifts or using pallet movers or dollies or trucks to deliver the parts. This can be or may be a result of poor plant layout or a poor cell design that needs extra transportation, or that needs a transportation to begin with. And again, doing a batching process and long lead times and large storage areas or scheduling issues, they all contribute negatively towards waste. And again, transportation, any kind of transportation to deliver a product is considered waste because the customer is not paying for that. Another concept is called Constraint Management, and a gentleman by the name of Goldratt, he wrote a book which is called The Goal, and in that book he introduced a system of thought on the theory of constraints. And additional books have been written on the subject, on the theory of constraints. And this book, which was written by Goldratt, it describes a process of an incremental, ongoing, continuous improvement activities. So what is constraint management? It's anytime we have a bottleneck in an area, in a process, that limits the production or a throughput in a process, that is defined as constraint management. So bottleneck is an issue, and we should aim to remove or eliminate the bottleneck areas. And if a process or anything we do results in an ongoing improvement, and we want to make sure that ongoing improvement is effective, the first thing, not just the management, but everybody should know what to change. Just because we need to improve does not mean that we start improving everything. We need to know what to change. We need to know what to improve. We need to know what to eliminate, what kind of waste to eliminate, so that we are productive, we are producing or generating more dollars for the company and providing jobs. To find an area which has a lot of constraint, a good way to do that is try to create a process flowchart, and over there talk about it, and this process by itself will show which area or which activity is causing the bottleneck. So you can, based on the process flow, nail down the problem area and then try to resolve the issue. The other way to do that is you can do a current state value stream map, in which you can look at, just by the nature of the current state value stream map, if you follow that process, you document all the value added and the non-value added activities, and then from there you can determine what needs to be eliminated so that more value is added to the process and to the company. So we talked about this in the previous slide. So theory of constraints. We'll talk more about theory of constraints under section 5, which is goes under the DMAIC D acronym, and that is define. So under define we'll talk about projects, tools, and results, and that will take care of the theory of constraints, which we'll talk more in detail when we get there. Some of the things that we can use, the tools that we can use to achieve this kind of purpose is we can use the tree diagrams or process decision program charts, and these we'll talk about it later. these are good tools to identify the constraint, the type of constraint we're having, and which areas are having those kind of constraints, and to make a decision by using decision program charts. The goal, which was written by Goldratt, it's by the way, it's a really good book, and I recommend that everybody reads it if you can find it. It describes a struggle about a plant manager, and he is trying to improve at the same time his operations and his plant, and then his marriage. So it's an interesting book. The actual theory of constraints is never mentioned as such in the book, but it is fed in bits and pieces, and you'll understand once you read the book. So listed are the theory of constraint areas that can be improved. For example, first one is bottleneck, second one is throughput, and you can read down these items. So these are the elements that on which we can apply the theory of constraints. The main goal of the book, the goal was that there are three basic measures that we need to use when we evaluate a system, and those three measures are throughput, inventory, and operational expenses. In the next slide, we'll talk about and compare it to the others measures, how important these are. So we talked about this, and we talked about this in the previous slide. So these three items, they reflect a true system than if you are looking at a machine efficiency or equipment utilization or a downtime, or you're trying to balance a plant. If you look at these three issues that the book talks about, they are critical to evaluate a system and to make an improvement accordingly. Using the theory of constraints, what can happen is we can identify the goals of the company and define the goals of the company, and at the very end we can also define the metrics that are needed and are critical measures to make improvement. And that is it for today. So we are done with lesson number 30, and thanks for your participation. We'll attach the reference material with the video itself so that we can review according to your own convenience. And then if you have any questions, please feel free to contact us through our website, and we'll respond to it right away. Thank you again. Thanks again for your participation. Have a wonderful day.